They were told to open all windows to allow air to get in and to decelerate the whole thing. There was no question at the time of braking at 331 kilometers per hour. We just didn't know how to do it.
Today, engines allow for testing emergency stops at such speeds. The 390 tons of the latest trains will stop after 3,000 meters. The CC only stopped after 10,000 meters, and there was severe damage to the engine.
The CC had destroyed its transmission system and melted its pantograph. It had reached the limits of feasibility.
The CC had broken the speed record. Yet when it arrives at the platform, the feat is not made public. The top brass at the SNCF has issued a directive that the results shall not be communicated before the second day and the performance of Schneider's BB train. There's fear that one of the two engines will be significantly less efficient than its competitor. The financial stakes for both companies are colossal. State orders for new trains would ensure business for years. The next day, March 29, 1955, it's the turn of Schneider's BB to attempt the world record. After a few minutes, the train reaches a maximum speed of 331 kilometers per hour. On arrival, the results of the two tests are finally announced. Surprisingly, it's the same speed for the BB and the CC. It's a figure that satisfies everyone, but it's not true. The CC never reached 331 kilometers per hour, but stopped at 320. It could have gone faster, but for safety reasons, it was decided to make do with this speed. So the record, in fact, properly belongs to Schneider. What's more, the Schneider BB achieved this record with a handicap compared to the Alstom train. The day after the CC's performance, the temperature had risen considerably. On the day of the BB's run, it was much warmer.
A difference of almost 10 degrees Celsius causes a noticeable relaxation of the catenary.
A relaxed catenary poses the risk of considerable undulation when the pantograph exerts pressure from below.
And that hinders current collection.
Without these power cuts, the BB might have gone well beyond 331 kilometers per hour. Yet its performance close to the Alstom engine suits everyone. And the news of a world record set by two different engines resonates across borders.
It made news headlines, regional as well as national, and even in the international press. 331 kilometers per hour was the absolute world speed record for trains at the time.
The double feat set an example for all countries looking for solutions in future rail traffic. The manufacturers, Alstom and Schneider, would charge a high price for their know-how, as the world market for trains offered spectacular possibilities. But these exploits also whet the appetite of other companies. 2 years after the dual-speed record, an engine straight out of the future sees the light of day. The ambition of its makers to shatter the state-financed record by surpassing 350 kilometers per hour. It's called the Aero Train. This exceptional invention with its unique mechanics, which makes conventional trains look totally outdated, is the brainchild of Jean Bertin, an ingenious inventor in the field of aeronautics, a daring entrepreneur, and a major player in advanced post-war research. His latest project, the Aero Train, is a kind of rocket propelled horizontally by a system quite different from trains.
To move at high speeds, the Aero Train blows air under itself. It then lifts up by a few centimeters thanks to its air cushion and thus almost completely avoids friction.
It's a technology that has dispensed with the wheel. After thousands of years, it was a gigantic step.
The Aero Train runs on an inverted T-shaped rail. A turbine drives fans that raise the whole configuration. The Aero Train then rests on a real air cushion. A second helicopter turbine, positioned at the rear, drives a propeller of 2.4 meters in diameter, composed of 7 blades.
You just have to push, and on its cushion of air, it will move at an extraordinary speed.
There is still air resistance, but no more rolling resistance.
However, it takes another 10 years of studies before the ultimate prototype of the Aero Train enters the race, demonstrating to the world that it's the future of high-speed transport. On January 22, 1969, Jean Bertin launches his horizontal rocket on its concrete rail. The peak speed obtained, as announced by the engineer, seemed incredible. 422 kilometers per hour, nearly 100 kilometers more than the 331 kilometers per hour of the previous record. While Jean Bertin continues to work on the prototype of his Aero Train, the engineers of the classic railway are embarking on a new project. It has to be revolutionary as well, with a new design, a top speed never before reached, yet inspired by the Aero Train in its motorization. The principle of the Aero Train is adapted. The train will produce its own energy without the help of a catenary. Inside the engine, a gas-powered turbine will activate an alternator, which in turn will create electricity, which then will feed the motors in the bogies. This new system will allow trains to run even faster and to break the existing speed records. The TGV is born.
TGV simply means high-speed turbo train.
The challenge for the railway engineers is set: to demonstrate the level of technology achieved by surpassing the existing record with the highest speed ever attained. But to do so, they will have to transform the old trains that have served their purpose by new engines adapted to high speed. For the first time, a train isn't pulled by a locomotive, but made up of 2 motorized cars at each end that can run in either direction.
This is extremely important. A train that is reversible allows us to use it much better.
If trains go faster, traffic on the tracks will intensify. Therefore, it's necessary to be able to save time on shunting in stations. Thanks to the new design, trains can leave in both directions. And that's a definite plus compared to the Aero Train, which can only run one way.